everyone. Welcome to the security track at GitHub Constellation 2022. You're joining us on day two of our event. I'm your host Dhanashree and I'm joined by my awesome co-host Amol.
Thanks, Dhana. Good morning and a very warm welcome to all our viewers today. I'm Amol Rana and I'm part of Advanced Security team at GitHub.
As you all can see, much like GitHub Advanced Security helps with your security posture, Amol and I have put on these detective hats in the hopes that it'll inspire today's security track. Why don't you all share your funny pictures and tweet us and use the hashtag GitHub Constellation? You could win some GitHub swag. By the way, Amol, how long have you been with security?
Dhana, I have been fortunate to be associated with security for almost 18 years now.
18 years? Whoa, Amol, that's a long time. You must have seen a lot of changes, right?
Yeah, that's true. It has been an amazing journey to witness how application security actually transformed from just being a penetration test to a complete DevSecOps deployment. By the way, Dhana, we have so many cool sessions going on in the DevOps and community track right now. How can the audience not miss anything?
Absolutely. So, if you all can't stay live with us all day, or you're also interested in some of the other tracks, we won't feel bad, but don't worry. We'll be posting video on demand streams here at githubconstellation.com after the event. By the way, Amol, didn't you just get back from an incredible work trip?
Yeah, Dhana, it was not all work and no play. I got to participate in some fun activities like golf, which I love, and table tennis with our advanced security colleagues in UK.
Hey, that looks like so much fun.
Yeah, it was. We also met the co-founder of CodeQL, Oge. What a great personality and visionary.
Hey, that's great. What cool insights did Oge share?
Yeah, we spoke about the new cool features on AI and ML we are going to be bringing in to GitHub Advanced Security. Well, that's, I think, enough about me. Dhana, what do we have lined up next?
Well, Amol, next we have Xavier coming up with the Securing the World Software Together session. Over to you, Xavier.
Hello, GitHub Constellation. I am happy to be with you today to present this session, Securing the World Software Together. My name is Xavier Onekorai. I am the director of the GitHub Security Lab. The mission of my team is to help secure all open source software by making security easy for developers. What's the problem that I want to talk about today? Vulnerabilities in open source. Vulnerabilities in open source code can have a global ripple effect across the billions of developers and services that rely on it. The whole software industry has decided to combat this problem, and they are investing quite a lot in security audits or initiatives such as the Open Source Security Foundation. But to succeed, these efforts must not be made just for you, open source developers. They must be made with you. So I will explain why with the recent example of the Log4Shell vulnerability, and then I will give you developers a strategy to improve the situation with 3 easy steps to start going without any effort, promise. So let me first illustrate the problem with the recent example of the Log4Shell vulnerability. Log4Shell is a critical vulnerability that happened in the Log4j library 6 months ago. Log4j, it's a Java logging library, one of the most popular and used library in the Java world. This vulnerability allowed attackers to very easily execute any arbitrary code on your servers. It could also leak private information from them. It was named by the press the most severe vulnerability ever, impacting hundreds of billions of devices, 93% of enterprise cloud environments. It even provoked an open source security summit at the White House. So you can also see that this vulnerability has arguably the ugliest logo ever, but that's not relevant to our problem. But you know what? There is even more to the story. What is worse is that this scary and critical bug pattern was discovered and described in 2016. It's a GNDI injection. GNDI, the Java Naming and Directory Interface, it's an API that provides naming and directory functionality. You have the possibility to look up for Java objects in a directory. A GNDI injection is when an attacker is able to inject code inside of this lookup. This bug was described and presented by Alvaro Munoz at the world's biggest security conference in 2016. But this announcement didn't make it to the developers of Log4j, or it didn't translate into a thorough code review and fix. And then 5 years later, an instance of this critical bug remained unnoticed in one of the most used Java library. It's a shame. It could have been fixed in 2016. But no, unfortunately, despite the work of the security experts, developers, maintainers fail to act upon it. Wait, is it really the maintainers' fault? I could say instead, security experts failed to convey a compelling message to developers, or security experts failed to transform their finding into a clear call to action for developers. Let's stop the blaming game. The problem is simply that the message doesn't pass from one community to another. So what's my solution for this problem? My solution is to empower maintainers and developers so that they know there is a vulnerability, they know what to do about it. Imagine that if we had this solution back in 2016, then the GNDI injection would be described, and then developers would know what to do about it, and then they would actually act on it, and we would avoid the Log4Shell problem. Why would this solution work? So let's take a look back at the last 2 decades. At one point, software had a big quality problem, and we solved it not by hiring more testers. That didn't work. We solved it by empowering developers to test themselves. It worked when developers could write themselves tests as code. Can you imagine now saying, oh no, testing is not developer's job, it's someone else's job? Obviously, no. The same thing happened with the DevOps movement, right? We empowered developers to understand and manage infrastructure with frameworks such as infrastructure as code. So I say, let's not reinvent the wheel. Let's learn from the past what worked, right? And let's take the same approach for security. Let's empower developers. This is what we are trying to do at the GitHub Security Lab. Our mission is to help secure open source software. The word help here is very important. We don't want to do it for you. Actually, we wouldn't even be able to do it anyway by ourselves with just a team. No, we want to do it with you. So what do we do in the Security Lab? The core of our activity is security research. We audit open source projects, we find vulnerabilities, we report them to the maintainers, we help the maintainers write a fix for this vulnerability. We also educate the community. We write educational articles, we give training, we give talks at conferences. The third thing we do is that we try to scale the research that we are doing by performing variant analysis. What is it? It's a process of finding other instances of a given vulnerability into other places, into other code bases. And then finally, we curate the GitHub Advisory Database. It's a database of all known vulnerabilities. This database is free and open source, and our team makes sure that the data in there is accurate and that it's valuable, that it's actionable information for developers. We do all of this for free. We're using tools that are free for open source, such as the GitHub Security Suite, for example. And we are following 2 foundational principles. The first one is that we want to empower developers. We are working to make security easy for you. The second one is that we try to build a bridge between the 2 communities, security researchers on one hand, developers on the other hand. If we don't want to repeat the Log4Shell nightmare, we need a better collaboration between these 2 communities. And fixing this collaboration is the most important thing we do. We conducted a socio-technical research among these two communities, and we discovered several improvement areas in the way these two communities interact during the vulnerability reporting process. For example, open source maintainers who receive a security report might have an initial reaction of stress, especially when the severity is high. It's never fun being on the receiving end, they say. Also, most open source maintainers have a day job that they may pause to address the security issue and protect their users. So we are working to make the security community understand that, and we are working to foster more empathy with the maintainers. The goal is that the maintainer receiving the report finds the experience positive, as in this second quote in this slide. It will never be fun, right, to receive a security report. It will never be fun. But the goal is that a maintainer receiving the report is happy because it means that their project will soon be more secure. So this is, in a nutshell, what we're doing at the Security Lab. But what about you? What should you do to improve the situation? In the rest of this presentation, I will first give you 3 easy steps to start your journey, and then give you a strategy to go further. Let's start with the 3 easy steps. They are super easy. They are like push a button, write 5 lines of configuration. Super easy, but they already go a long way toward being more secure. Our first step is to create a security policy. The goal is to tell security researchers how to report a vulnerability to you. In its simplest form, it's just a file containing a private email address. You might find this first step too simple. Know that finding this information is the #1 struggle of security researchers when they want to disclose a security bug. Imagine that they find in your project a scary issue like Log4Shell. Without this information, they will either not report the issue, or they will report it publicly in a public issue of your project, for example, but that would be visible by attackers. So yes, it's an easy step, but this step has a big value. So big return on investment. To do so, follow these steps. You go to the security panel of your project, you click on security policy, you click on the start setup button, you write your file, you commit your file, and again, the file can be as simple as just 1 line with a private email address. Our second step is to activate Dependabot. Your open source project depends on other open source projects. A vulnerability existing in one of your dependencies can be exploited for your project and harm your users. Fortunately, when these vulnerabilities are discovered by security researchers, they are recorded in the GitHub advisory database, along with information such as what are the vulnerable versions, what are the safe versions, what are the versions where this vulnerability has been fixed. So when you activate Dependabot, if your project depends on a vulnerable version of a dependency, Dependabot will alert you and tell you, hey, you should upgrade to this safe version. If possible, it will even open a pull request for you that you will just have to review and merge. To activate Dependabot, go to the settings of your project in the code security and analysis section, and just click the buttons below to enable Dependabot alerts and Dependabot security updates. Let me give you an example. When the Log4Shell advisory was published, was inserted into our GitHub advisory DB, Dependabot sent alerts and pull requests to more than 500,000 projects. And 48% of these projects that were active upgraded to a safe version in less than 1 week. To know more about GitHub security advisories, Dependabot, etc., there is a nice presentation later in this track by Kate Catlin and Madison Oliver about the GitHub advisory database, so don't miss it. Step 3 is activate CodeQL. While Dependabot will find existing known vulnerabilities into your dependencies or into others' code, CodeQL will find new vulnerabilities in your code. What it does is that it exports your code into a relational database, and then it queries it to find bug patterns. It can run in your pull requests so that it detects your bug even before they reach to your main branch. And basically, it automates the community expertise into these queries and make them available to you to run automatically on your code. So you benefit from this community expertise without doing anything. To activate Dependabot, you open the action tabs in your repository, you click new workflow, and you select the CodeQL analysis workflow. You will have a few lines of configuration and you'll be ready to go. With these 3 steps, we are starting bridging the gap between security researchers and developers. We are making the work of the security researchers translating into actionable solutions for the developers, for the maintainers. And these steps work. If you want to see a real example of that in a real life project, my colleague Kevin Bathhouse will present a case study later today in his talk, Practical Tips for Maintainers to Improve Your Security Posture. Don't miss it. But this is quite passive, right? You just click on the button, you automatically get more secure. But how about being proactive for your project security? After all, we want to empower developers. Well, to do that, obviously, you need to learn. You need to learn to be empowered. The goal here is not to transform all developers into security experts, but to teach them the basics, the fundamentals of security. What you can do, you can follow our Twitter account to get updated of new content we are publishing, to get security tips. You can also go to owasp.org to get free great training, or you can go to the Open Source Security Foundation training, to the openssf.org training. Later today, my colleague Alvaro Munoz will give a talk about the great content that you can find from OWASP to start your secure code learning journey. I also advise you to practice. One thing you can do to practice, for example, is you can volunteer to address the security issues, security problems of your favorite open source projects. And finally, CodeQL. CodeQL is a great tool to empower developers. Why? Because it's code. You remember, developers started to address quality when they could write tests themselves in code. Same as operability matters, they loved infrastructure as code. Here, it's the same. CodeQL is code. And you have the possibility to contribute to the queries by adding your knowledge of your code, of your project into this query, right? I encourage you really to contribute, because it's best when you can mix the two knowledge together, the security knowledge on one hand, your knowledge of your project on another hand. That would make a wonderful query to protect your project. To start your CodeQL exploration, check out the presentation from Joseph Cassiodes, Find Bugs in Your Code with CodeQL, later today in the security track. Also, know that CodeQL is just a tool to explore your code, right? So yes, you can find security bugs, but in fact, you can find any kind of bugs. So try CodeQL, you will be able to find immediate value with it. So it's time to wrap up. So what did I tell you? I gave you 3 easy steps to start your security journey. Create a security policy, activate Dependabot, activate CodeQL. You can find how to do this in the GitHub documentation. To go further, I recommended you to take some secure code training for the basics, the fundamentals, and I recommended you the OWASP.org trainings or the Open Source Security Foundation, openssf.org training. And then try CodeQL. If you try CodeQL, there is a capture the flag contest running as we speak in GitHub Constellation. So you will have the possibility to, 1, have fun with CodeQL, and 2, possibly win some nice GitHub swag. Thank you very much for listening to me. You can find us on Twitter at GH Security Lab, myself at XCOI. Don't hesitate to ping us or follow us for more content. You can also visit our website to read and consume the content that we are providing, but you can also get involved in various ways if you want to join our community and help us secure open source. Thank you, GitHub India. Bye.
Wow, thank you, Xavier, for sharing all those amazing recommendations and tips. That was an amazing session by Xavier, right, Amol?
Yeah, Dhana, I completely agree with him on importance of security in open source.
Yeah, a lot of us faced a Log4 shell vulnerability too, right?
Yeah, exactly. So it was great to hear how GitHub Security Lab is doing some fabulous work for all community.
Yeah, so who do we have coming up next, Amol?
Well, our next speaker is Saurav Pathak. So Saurav is a VP products at Bagisto, and he will be speaking on how they secured the open source project Bagisto. So over to you, Saurav.
Good morning, everyone. My name is Saurav Pathak, and today I'm going to speak on the topic of Community Spotlight Securing Open Source Project Bagisto. Now, what is Bagisto? Bagisto is an open source e-commerce platform that is built for merchants to begin their e-commerce journey effortlessly. It is based on some of the popular technology, Laravel and Vue.js. Laravel, which is one of the most popular PHP framework with elegant syntax that makes the development process simple without sacrificing application functionality. Now, Bagisto is not just another e-commerce platform. It's more like a platform-driven commerce, a commerce which is made for the developers, by the developers, but very simple uses by the merchants. So any developer community or a developer who is having a good experience of working on OOPS concept or CRUD operation on any framework, they can easily use Bagisto to make their own e-commerce platform. Bagisto is offering a more of like a post-commerce solution. So it's not just a commerce that you're getting with Bagisto, but a many different use cases. Like you can build marketplaces, you can build mobile apps, you can build your progressive web apps, POS solution, SaaS solution, a live streaming solution, and many more you can have with Bagisto. Now, Bagisto, Bagisto is having more than 10,000 plus live websites of merchants running live on Bagisto, and there are more than 5,000 plus community members who are like actively participating in Bagisto. Now, when we talk about 10,000 plus live merchants and the merchants having a billion product SKUs, security plays a major role for us in order to continuously improve Bagisto and keep it secure from for all the vulnerabilities and the scripts running in Bagisto. Now, in order to follow a good security practice, there are two levels. One is the one that we implement at the core level, and second is the one that we follow for the community contribution level. So the very first the level I'm going to discuss is the code development process and what security practice we follow. Now, Bagisto is made on Laravel. So we are using the Laravel authentication system, which is a robust user authentication process. Laravel uses, providers, and guards to facilitate the authentication process. Bagisto has strengthened the hashing algorithms SH256 used in password management. Bagisto now supports Argon 21D13 through the PHP Sodium extension, which requires the libsodium library version 1.0.13 or higher to prevent the brute force attacks. To protect your application from CSRF attack, we are using CSRF tokens in each request to avoid external third parties' fake requests. Bagisto limits a request in some paths like JWT authentication, etc. to prevent the DDoS attacks. We are using Laravel's Blade syntax. Now, Laravel Blade is one of the theming components of Laravel. So the Laravel Blade syntax will escape any HTML objects to prevent the cross-site scripting vulnerability. For the sequence injection, we are protecting against that by using prepared statements, which are going to escape any user input that may come in through your forms so that attackers are not able to add their custom queries. We are properly validating all the requests to avoid unnecessary data insertion in the database. We are properly managing all the session handling paths for both the customers and admin section portion, which are having a different guards as well. We are regularly checking all the third-party dependency. Like for Magisto, there are a few third-party dependency which we use, like social logins or like socialite function. So we keep a check on all the third-party dependency that we use, that if they are up to date, if there is not any security vulnerability, and then we make sure to make use of third-party dependency in Magisto. So a simple admin URL like an admin or a backend makes it easy to target attacks on specific location using automatic password caching. To prevent against this type of attack, Magisto by default creates a random admin URI when you install the product. So suppose it's a very common guessing that if there's an e-commerce and if I want to open a backend, I can just type the URL of the e-commerce store, and after slash, I can put admin or like admin login. Now that is a very common guessing for any type of attacker. But with Magisto, we are not doing that. We are randomly changing the URL, so it's hard for attacker to guess what would be the proper URL for the admin. It makes the admin panel quite secure to log in. Magisto no longer explicitly sets file system permission. Instead, we recommend that certain files and directories be writable in a development environment and read-only in the production environment. Magisto safeguards your store from click-jacking attacks by using an Xframe option HTTP request header. From time to time, we also publish security report from our security teams whenever they identify a vulnerability. So they publish those bugs with a proper CVE number and also a resolution. So in that report, you can get a more detailed version of a CV number of a bug which is like universally accepted, and you can also get to know that in which version of Magisto we have fixed that bug. So the version number of the Magisto is also mentioned apart with that bug. Now Google Recaptcha it provides a greater level of security for both the storefront and admin URI that is available with standard CAPTCHA to verify customer accounts and enhance security when admin users log in. Magisto also prevents cache poisoning, so no one can change the cache contents to include different pages from the same site. Magisto also secures cron.php to run in a browser to prevent it from being used in a malicious exploit. Magisto two-factor authentication improves security by requiring two-step authentication to access the admin UI from all the devices. When security vulnerabilities are discovered by the researcher, proper reporting channels are often lacking in various open source platforms. As a result, some vulnerabilities are not reported properly. The purpose of having a security.txt file format is to give the security researchers the information they need to report the finding. So in the txt file, we mention in what format you need to report the security bugs of the find, and that way we get the mail from different researchers, and also we do have a bounty programs as well where we reward the reporter with some bounties. So community plays a very important role in the population of any open source project. How much open source is popular, it depends how many active community members are there and how many people are using the project. Now at Magisto, there are more than 5,000 plus active community members who are actively participating in maintaining the project as well, and also like checking on the vulnerabilities and adding PRs and so many things. Now with community, what comes, there are so many pull requests and you need to keep a check on those pull requests if those pull requests does not contain any malicious scripts which can hamper your open source project. So with Magisto, with so many merchant sites running and with the community participating in the open source, in the pull request for Magisto, we need to keep a proper check on those. So there are a few things that we follow a lot. The very first thing are the test cases. So we have prepared unit and functional test cases which are regularly run on each pull request with the help of CI/CD pipelines, which are integrated via GitHub workflow. These pipelines are a practice focused on improving the software delivery throughout the software development lifecycle via automation. In this way, whenever a new contributor creates a pull request, all the test cases are run automatically. And this is thanks to GitHub Workflow, a fantastic tool. It has really pulled out a lot of stress from our maintainers who keep a check on the PRs. So it's not like we need to check all the PRs line by line for each and every code. We have all those test cases prepared for unit and functional testing. And those test cases make sure that all the PR pass through all the test cases. And once they have passed, then only that PR comes to our maintainer for checking the field business logic and the functional testing. On every new pull request, our maintainers regularly reviews all the codes for the functionality checks, vulnerability checks, as well as the code priority also. Last, even we have enabled security policies, security advisories, and dependabot alerts, which tell us about the latest vulnerability and fixes as well. In this way, we make sure that we at least don't have any vulnerability in our dependencies as well. So these are some of the best practices that we have followed in the core code development process and also in the community contribution. While following all these processes, we make sure that Baggesto remains secure for its merchants who are using and for the merchants about to come to use Baggesto. And since the Baggesto follow all those security practices, that makes the e-commerce very much secure to use, and also our promise and trust the merchant that have on us to keep delivering a good e-commerce platform. So that's all from my side. Thank you all for your time.
Hi, Dhana.
Hey, what a great session, Amol. It was amazing to hear how our customers are using GitHub to solve real life challenges.
Yeah, I'm sure our viewers got some key insights on how to secure their open source projects by enabling security policies, security advisories, and Dependabot. So, Dhana, looks like our next speaker is a fellow hubber.
That's right, Amol. And I think you met him in UK as well. Grant Birkenbein is a security engineer at GitHub. He'll speak to us about top ways to secure your work. Over to you, Grant.
Hello, my name is Grant Birkenbein, and I will be your host today, going into back to the security basics using GitHub.com. Welcome to GitHub Constellation India, and I hope that through these talks, you guys will have a better understanding of how to secure your developer workflows using GitHub.com. So a little bit about me. The name that I go by on GitHub is Grant Berkey. You can find me hanging out a few open source repositories or working on the GitHub platform and other areas. I'm a security engineer who will be guiding you today along the journey of using best practices at GitHub and with the various services that you can interact with on GitHub.com. For example, actions, going through your own account settings, using SSH keys, GPG keys, all sorts of things. So a few fun facts about me. Outside of tech, I enjoy filmmaking and also documenting new places that I travel to. All right, so some topics covered today are going to be why you should focus on security when using GitHub.com. Who does this apply to? And how we can follow security best practices when we're using some of the services that GitHub offers. So let's get started. So first off, why should you focus on security when using GitHub? Well, this applies to a couple of different areas depending on who you are and what you're using GitHub for. So for example, if you're an open source developer, reasons why security might be important to you is to protect your community and promote safety and trust. So if you're an open source developer creating a new Ruby or JavaScript package, it's important that the people using your packages support and are confident that the package that they're using is going to be safe. So you really want to protect your community when you're developing in the open source area. Also for commercial reasons, let's say you're a company and you use GitHub.com. Well, you want to protect your customers and the people that are paying and using your services. And if your services involve software, you want to make sure that software is hardened, protected, and secure. You also want to comply with local laws and regulations, and you want to ensure that what you're doing on github.com falls into that category and you are complying with those laws. If you're a personal user of github.com, maybe you're a student, a teacher, you're just trying to learn, kind of get your hands on with open source, it's important to protect your data in your GitHub account, just like you would do with any other account online. So whether it's a social media account or a website, that you're logging into for studying with school or anything like that, just like you'd protect your data and information there, or for example, with banking, you'd want to do the same and protect your GitHub account online as well. All right, who does this apply to? Well, this applies to everyone. So whether you're a software engineer, data scientist, mobile app developer, contributor to an open source project, an auditor, researchers, students, anyone and everyone. There is no exclusions for who should follow security best practices. Everyone should. All right, let's begin. So I'm going to get into some of the top ways that you can secure your experience on the GitHub platform. Okay, so starting with number one, we have password security. Now, you've all heard this before. Passwords are important. You should have long and complex ones. That is the case, and that is certainly the case with GitHub. So a fun fact is that an IBM study published in 2021 found that 82% of workers today reuse their credentials in some manner. That's not exactly a fun statistic. Working in security, you don't want to see that. So we want to try to do everything we can to prevent password misuse, especially on GitHub, where you could be developing software that's important to you and your community. It's important to have a good password and also make sure it's secure. And there's a couple of tools that we can use to help us get there. So step number one is never reuse your passwords. All right, that's the biggest thing that you can do, is ensure that your password is not reused in another place. Because if there's a data breach at company XYZ and you're reusing that same password on github.com, it can easily be reused in a credential stuffing attack where an attacker just takes that password and tries it on many different websites. And if that password works on github.com and you don't have two-factor authentication enabled, which we'll get into in a moment, that password will just work and it'll log into your GitHub account. We don't want that. So don't reuse your passwords, number one. Number two is never share your password with anyone. GitHub is never going to email you asking for what your password is. And if you see any emails like that, it's likely a phishing attack. So definitely don't follow up with that. Don't send your password to them. And don't share your password with anyone else. Step number three is going to be use a complex password. So use a password that's comprised of alphanumeric characters, numbers, symbols, and make sure it's long, right? So don't be using like a 5-6 character password, use a longer password, and that can really be accomplished quite easily by using a password manager. Password managers, if you're not familiar, they're a tool or application that you use. Sometimes they're based on your web browser. So for example, Google Chrome has a built-in password manager tool. There's also extensions and plugins that you can use, some free, some paid for, that can help you manage that as well. So you log into your password manager with one complex password, which you remember, and then from there you can generate random and unique passwords for each website that you log into throughout your day. So that's a great tool to use as password managers. And there's a couple that I recommend here. So there's KeePass, there's KeePass XC, which is a fork of KeePass, and it's open source and free. You can use it on Linux, Mac, Windows, wherever you want. There's some other options as well. 1Password, LastPass, Bitwarden. I've linked at the bottom KeePass XC just because it's an open source option, and you can get started with that today for free. There's other options as well. Just as long as you're using a password manager, you're going to be a lot better off than without one. All right, so number two, the next thing you want to do if once you have a strong complex password is you want to make sure you're using two-factor authentication. So two-factor authentication protects you from phishing attacks, credential stuffing attacks, and the sorts. It helps protect you because in addition to entering your username and password, you also have to take a second step to log into your account. That can be an authenticator app, as you can see on my screen here. This is actually what I have configured for my GitHub account, and I would suggest users to follow the same. You can set up a authentication app, add security keys to your account, or you can even authenticate with GitHub Mobile. So once you enter that username and password, it's going to prompt you for a two-factor authentication. So it's going to prove that you, right now in the present, are trying to log into your account, and it's not an attacker located in some distant land trying to log into your account. And then, fun fact here, 2FA is a simple action you can take to prevent 99.9% of your attacks on your account, according to a senior product manager over at the Microsoft security team. So to access this page here, there's a link right at the bottom. Go to your github.com settings security tab. All right, step number 3 to protect your GitHub account, committing credentials. This is not something you want to do, but it is something that we have most likely all done before. I would actually consider this a rite of passage in software development. You might not be a true software developer unless you've committed credentials at some point in time. That's a joke, of course. But yes, we've all done it many times before. To date, GitHub has detected more than 700,000 secrets across private repositories through GitHub Advanced Security Scanning. So it's something that happens quite often. And there's a few steps that we can do to reduce the risk of this happening. So if you're an open source developer, you're probably familiar with the gitignore file. The gitignore file is a file that you add into your repository, and it excludes files from being committed to GitHub. So Git will not track those files. So if you have a file called secrets.txt in your gitignore file and in your repo, it will never track that file and prevent you from committing it in the first place. So that's a good first step to preventing this from happening. However, you could add your secret someplace else. Maybe have it hard-coded in instead of using an environment variable in one of your source files, and that could be committed. So to prevent that, you can use an open source tool called Git Secrets, made by AWS Labs, which creates a post-commit hook. So after you do a commit, it's going to scan and see if you have any secrets in that commit. And it's going to alert you before you push that secret to a private or a public repository. So that's a great way to kind of prevent that from happening. GitHub actually suggests using the GitHub desktop app. Personally, I'm very integrated with the command line, so I don't use it all that much, but it can help new developers and students to use a desktop app or even Visual Studio Code for checking what you're going to commit, because you can see kind of in a visual display what's being committed and kind of help you prune out any chances for you to commit a secret before it happens. And if all else fails, if you do commit a credential, GitHub is actually partnered with several organizations to help reduce the risk there. So if GitHub detects, for example, AWS access key and secret key has been committed to a public repo, we're going to reach out to AWS and try to revoke that credential as quick as we can. So AWS will get a notification saying that their credential has been committed. They're going to go ahead and try to revoke that credential for you. And the goal there is to try to get rid of it before a bad actor can use it. We have a ton of different partner organizations that we do this with, and the full example can be found on our documentation page. For enterprise developers, we have a couple of different options, and one of them that's pretty cool is GitHub Advanced Security Push Protection. And what that actually does is it will prevent you from pushing a commit if GitHub detects a secret in it. And we do that by some different pattern recognition. So if we detect a AWS access token being pushed to a GitHub repo, we'll reject that commit. Now you can always go in and approve it and let it be pushed. For example, if you're trying to test something or test a credential being revoked, you can do that. But it's nice to have that extra layer of comfort, especially for enterprise organizations. Okay, here's a quick demo of seeing how push protection works. So here we see a user has intentionally committed a secret, and they're going to push that change to the repository. And once they see that come through, we see right away push protection is going to notice that a token was committed, and the user is actually going to go ahead and click through and allow it to happen as an exception. So it was a false positive, and they're going to allow it to be pushed anyways. So that's just a quick demo of how that can be done. There's more examples on our documentation page of this, and there's also a blog post as well. All right, number 4 is going to be security related to your personal access tokens. So if you're not familiar, a personal access token allows you to interact with different services in GitHub, for example, the API. And so, for example, if you wanted to test out a script locally where you're going to label a pull request as a bug, you would create a personal access token to do that. So here you see on the left, I'm creating a personal access token for a deployment status bot. And a couple of things that you can do to protect this is, first of all, treat your paths like a password. Don't share them, don't commit them, keep them safe. Use short expirations. So you see I have a testing token here. I'm only going to have an expiration for 7 days because I don't plan on using this token all that long. Next, I'm going to select only the scopes that I need. So here I've only selected repo deployment because that's the only part of the API my testing bot will be interacting with. All right, number 5 is going to be SSH keys. So SSH keys allow us to do many actions related to Git and GitHub. And by doing so, we don't have to use our password. So rather than using git clone and using your password to authenticate and pull down, for example, a private repository, you can use SSH keys. There's quite a few benefits for doing this. So for one, using SSH keys allows you to reduce the amount of times you're using your password or possibly misusing your password for Git operations. So the less times we're using our password, the better, because each time we use it, it's a chance that we could accidentally copy and paste it into the wrong spot. SSH keys also allow you to create a unique key for each device. So for example, if you have, let's say, a work desktop and a personal laptop, or vice versa, you could be using an SSH key on each device. One has access to git clone repositories related to your work and organization, and the other is just for personal use. That helps kind of eliminate or shrink down the blast radius of what keys can access what repositories. So you can see here, you can turn on or off SSO on a per key basis. You can also protect your keys with passphrase for one extra step of security on them. And you can audit and revoke your keys as needed. So if you notice abuse on one of your keys, you can go ahead and revoke it, create a new one. All right, GPG keys, number 6. GPG keys are a little bit more of a complex topic. I'm not going to go into how they work under the hood. You see here at the top, magic math and cryptography. At a very high level, it uses private public key cryptography to sign and encrypt messages. That might be a little bit overwhelming just of a concept. So if it's interesting to you, I suggest that you explore it outside of this talk. But I'll just give you the core pieces of what you need to know for GPG keys here. So here we can add a new one. You see on the far left, you can add a new GPG key to your account. And then once you do, when you make a commit using that GPG key, using Git locally, you'll have a little verified badge that pops up. And what that is doing is it is signing your commits to cryptographically prove that you are the one that pushed that commit. So you're not being impersonated by someone else. This is you who made that commit and no one else made it. So you can add a key to your account. You can use that to sign your commits. And then an optional bonus option is you can enable vigilant mode. So any commit that is not signed is going to be flagged as unverified. A little tip also for open source contributors, just going back to the slide real quick. It's really helpful if you're like maintaining a package that other people are using to have signed commits, because people are really going to want to know a strong chain of ownership of who's making commits and when, and make sure that there isn't any sort of supply chain attacks going on in your commit history. So that's a bonus if you're a dependency or a package maintainer. You should be using GPG keys. Number 7 is going to be reviewing your security log. So this has come up in recent topics. Checking your security log and doing so regularly is a really good option, especially if you notice anything suspicious with your account. So you can get to your security log by going under your settings page and then going under the archive section. You can see in the far left. You can also view your sponsorship log, but we're sticking to security here, so it's a bonus. Looking at the security log, you can go in and you can filter on different options. So you can see here I'm filtering underneath all actions that contain alterations to repository access and on a certain date. So let's say I was a little bit suspicious why one of my repos suddenly became public maybe I didn't want that to happen, I could go in here and I could see, okay, it looks like someone changed one of my repositories from private to public from Seattle on February 18th. Now, I did do that intentionally, but if I didn't, that would be a red flag. So that's what you can do with the security log, is review some of your security access and making sure with filters and drilling down that the actions being taken on your account are actually you and you trust them. All right, number 8 is going to be code security. This is also a little bit more of an advanced topic, and it will be talked by other presenters throughout this presentation. So I'll try to keep it simple here. So the top things you can do to protect some of your repositories in your GitHub account through code security would be by enabling some of these options you see on the left. So we see I've enabled the dependency graph, Dependabot alerts, and Dependabot security updates. We'll go into more about Dependabot later in other talks. So for now, all you need to know is you can enable these features for all of your repositories right in your settings page. And Dependabot is great. I personally use it in all of my repos because it will automatically alert me if any CVE or security vulnerability has popped up with the dependency that I'm using, and it will automatically open a pull request to update that dependency. So you can see here, in one of my Python projects, Pillow had a critical vulnerability, and Dependabot automatically opened a pull request, and I was able to update it right there in the GitHub UI to a stable and no longer vulnerable version. All right, number 9, we're going to be speed running this one because there's a ton that we could talk about here. I personally love Actions. I use it all the time, and I could go on and on for days about this. So we'll try to keep it really short here. So for Action security, there's a couple of just easy checkboxes you can enable to harden and protect your workflows. And lots of people don't know about these options, and they're really helpful to kind of lock down, especially your public repos, to make sure they're safer. So number 1 is you can specify where your actions and workflows can be used from and who authors them. So here I have set allow all actions and reusable workflows. If I wanted to really lock down my actions workflows, I could disable actions and then I wouldn't even be able to run them. Or below, it's kind of hidden, you can select only certain repos or owners to allow actions to be used from. So that's very helpful if you're using all sorts of different open source actions. You can lock it down to exactly the ones that you want. Also for running actions on forks from pull requests from outside collaborators, this one's really helpful. If you don't necessarily trust every single person in your community, you can lock it down to require approvals for either first-time contributors, and then subsequent workflows will run automatically, or you can require an approval for every single outside collaborator. You can also lock down your workflow permissions, so you can say, all right, I only want my actions that are running on my repo to have read-only access, or you can have read-write. Depends on what you're doing in your use case, but you can tone down your level of permissions with actions through some of these options. And number 10, the last way, and arguably the most important way to secure your experience on GitHub, is just using brainpower and common sense. If you see something, say something, follow security best practices, audit all the third-party tools and integrations and packages that you're using in your repos, and stay informed with security notices. There's a ton of great tools out there. There's the GitHub blog, which posts security notices. There's Hacker News, which you can follow about different CVE alerts. And for me here in the United States, there's some great government-run subscriptions that I can get notifications from if there's any sort of security alerts or really big vulnerabilities that come up in the news, for example. So something that our CSO likes to say here is we're all a part of the security team here at GitHub, and really everyone at GitHub, users, the employees here, everyone alike, we're all a part of the security team. We should all adopt a security mindset to protect ourselves and our contributors to our different projects. So thank you. Hope you guys learned something today, and I hope you are on your way in your journey to further secure your GitHub account and your experience. Thank you.
Wow, wasn't that some great insights by Grant on following security best practices when using GitHub?
Absolutely, Amol. Such common sense recommendations too. And you know what? I do agree with Mike Henley, our CSO. All of us are at GitHub, are part of the GitHub security team. Amol, did you hear about Grant's cool update about secret scanning?
Yeah, Dhana, push protection is truly a great game changer, and it's now included in secret scanning.
Why exactly is it a game changer, Amol?
Yeah, it's because push protection is more proactive in blocking secrets rather than waiting for a scanning tool to find them later on.
Ah, being proactive rather than reactive. That makes a lot of sense. Thanks, Amol. By the way, I loved Grant's last tip on auditing all your third party tools, integrations, and packages.
Hey, Dhana, I know Mohit and you had a lot of fun yesterday.
Hey, we sure did, Amol. There were super insightful comments from Thomas, Nandan, all our other panelists. And you should check out the replay video we have coming up to see why Mohit was wearing his snorkeling gear. Let's see a recap of day one.
Thank you for joining us this week. I'm here to kick off our third annual event in India, GitHub Constellation. We have so many great sessions for you, and I hope you enjoy them. Open source has won. If you are an open source maintainer, you're working on some of the most exciting stuff. Developers from around the world are working and collaborating together on open source. 2, the interconnected community is a powerful one. Open source, education, and enterprises, we are all in it together. We are building the future of software, and our mission is to accelerate human progress through developer collaboration. And 3, we are committed to India. We are committed to growing GitHub in India, to hiring in India, to supporting Indian developers, maintainers, and students by giving back through programs to GitHub sponsors, accelerate the open source bootcamps and externships.
This has led to a huge opportunity for India because India has become the place with the largest number of talent and developers. Just to give you an idea of the scale of acceleration, it took 30 years for the Indian software industry servicing the global market to reach $100 billion in revenue. The second $100 billion came in 10 years. And now the industry does about $227 billion in revenue. The third $100 billion is going to come in 3 to 4 years. I do believe all of you can play a huge role in building a bigger community of open source developers, in playing a larger role in global open source products, and launching India's own open source product that can be taken globally and therefore make a huge difference to the transformation of India and the world.
By the way, I picked up a new hobby and I wanted to show you my new camera to click the beautiful Bangalore rains. What are you up to with that snorkel?
It is so hot here in Delhi, Dhana. I'm just trying to use the power of manifestation to feel that I'm at a beach and trying to get rid of this hot summer.
I will use your program as a call for action to all the developer community to come and join hands with us to help us develop it.
I think there is a lot for me. I'm taking back from this discussion, and there's a lot for everybody else who's listening to you to come and contribute back to our nation building.
By the way, cool look, Mohit.
I'm just trying to match our cool Indian developer community and the coolest projects that they are contributing to.
Recently, I had an interaction and my Honorable Minister Ji spoke about, why don't you teach A, B, C, D, F, G to higher education students? I said, sir, they already know because, they studied about A, B, C, D in school. They said, no, I'm talking about A means artificial intelligence, B means blockchain, C means cyber security, D means data analytics and intelligence, E means electronics, F means faster coding. Maybe in his words, maybe faster coding. It means no code, approach. And G is GitHub. So this is where we see that GitHub is very, very important for our national education policy.
I see that Central Perk Cafe on your t-shirt. Friends, it's my go-to show. I have something interesting for you. Check this out.
Hey, is that Ross's monkey?
Yeah, that's Marcel.
We at ZE are looking at a 3-pronged strategy: tools, technology, and processes. Get the right set of tools which are easy to use, make them available to the developer so that vulnerabilities are highlighted at a much earlier stage. One of the examples is the integration of GitHub Advanced Security, which we have recently undertaken. Second, and most importantly, is train and sensitize the developers and equip them to be able to address the issues before the code is checked in. And finally, and most importantly, is to have the process and guidelines very clearly defined.
If there's a completely closed source option and there is an open source option, I tend to gravitate towards the open source because if you hit some feature limit or something like that, you can continue to extend at a code and contribute back. And so with Roy, we are building like a no-code platform that basically allows you to get started like a no-code, but then you can continue to extend at a code level anytime you need. And our experience with seeing how developers are extending it in different scenarios has been really interesting, various kind of use cases, and that has been a really good learning experience for us.
I think this is a growing trend today, so your experiences will help a lot of new startups and organizations who are going in the same directions as each of you did.
These were your hosts, Dhanashri and Mohit, signing off. Have a great day.
Hey, that looked like super fun, Dhana, and I'm sure it's not only North India, but even in West Bombay and Pune, it's burning, and I think I need to get a snorkel for myself too. And looks like we already have folks tweeting us, so let's bring on the first tweet.
Oh, so Rohit Shirke is tweeting at us, Amol. And he says, amazing intro by Nandan about how India is leading its way in software market and the contribution of OSS in the huge success stories of platforms like UPI. Oh, absolutely. Nandan shared such amazing stories. It was really, really inspiring. Let's see another tweet.
Completely. Wow, so the next tweet comes to us from Altargo. It gives me goosebumps to watch this. Such inspiration, GitHub Constellation. Thanks, Altargo. I completely agree with you. The team has put on a good effort, and I'm sure you really took back some good stuff from the event yesterday or today.
Do we have more tweets, Amol? We can bring on a couple more. Okay. Carrie Cool Dude has something to tweet at us. He says hashtag GitHub Constellation, which, by the way, all of you viewers, please use the hashtag. He says open source and community is the key to code, is Building India initiative from scaling the project to the product in the form of a startup. Is the journey that GitHub as a platform is providing. Absolutely. And we are so proud of the work we do here at GitHub every single day.
Let's bring on to the next tweet. Yeah. Wow. So who we have here is Nidhi Devang. So what Nidhi says is attending GitHub Constellation on importance of security in open source. At the rate GitHub Security Lab, learned, create a security policy, activate Dependabot, activate CodeSQL, secure coding training, CodeSQL. I think that's basically amazing. I think she continues intending, that's basically, I completely agree with you, Nidhi. That's what we wanted to communicate to our viewers today, that what's, in it for you when you look at DevSecOps. So I think that was an amazing tweet. Maybe do we want to give her a swag, Dhana?
Would love to. Absolutely. Nidhi, please DM us your address to our handle GitHub India, and we love to ship you some GitHub swag.
Yeah.
Isn't it so much fun to hear from our viewers, Amol?
I agree with you.
By the way, Amol, yesterday's session replay reminded me of some fun times. Would you like to hear some jokes?
Sure, why not?
I know this is corny, but here we go. I love the F5 key. Isn't it just so refreshing? Well, here's another one. I won't torture you with too many. One last one, Amol. Why doesn't Superman fight cybersecurity? Because he's afraid of cryptocurrency. So, do
Wow,
you
we
all have
both.
any funny? Well, sorry, Amol. Hey, viewers, we would love for you to join us in the fun. Do you have any funny tweets related to security? Tweet us and let us know. Please use the hashtag GitHub Constellation. Coming up next are our wonderful colleagues, Kate and Madison, with a session on helping secure your open source. Over to you, Kate and Madison.
Hi, everyone. My name is Madison Oliver. I'm a senior security analyst here at GitHub, and I manage our advisory curation team, which is the team that populates the data in our advisory database. I'm presenting today here with my colleague, Kate.
Hi, everyone. My name is Kate Catlin. I am a senior product manager with the GitHub Security Advisory Database team. So we do all of the engineering product work to transform those advisories that Madison's team has worked so hard on into a beautiful UI experience. And let's go ahead and get into the slides. So we are here today to talk about securing the open source world using the GitHub Advisory Database. Specifically, we're going to talk about what are security advisories, what is the GitHub Security Advisory Database, and what does that database power? And the first thing we're going to talk about is what is a repository GitHub Security Advisory. And I'm calling out the word repository here because next up, later down the line, Madison's going to talk about global security advisories, and those are a little bit different. So starting with those repository advisories, this is a feature that allows package owners to privately discuss and create a fix for a potential security vulnerability in the project that they own. So after collaborating on that fix and how they want to present it, repository owners can publish that security advisory to publicly disclose it to their community. So let's say that you are a maintainer of an open source package and a security researcher has reached out to you to say, hey, I think I found a vulnerability in your code. What do you do from there? Well, you can handle all of that right here from GitHub. So navigate to your repository, and then you're going to select the security tab on the top bar menu. You can see there's an orange line underneath it there. And then on the left-hand sidebar, you'll see security advisories. So select that menu next. And then you'll notice up on the top right, there's a green button that says New Draft Security Advisory. So you'll click that button. And I know this process can be intimidating if it's the first time, but we then walk you through a guided step-by-step experience where you're filling out one field at a time, really trying to break that down so that you know exactly what information to include to make this advisory as helpful as possible for the users of the package that you maintain. Well, a couple things I want to call out on this draft security advisory process. First is that you can request a CVE number directly through this. Madison's going to talk about CVEs a bit more later, but high level, this is a globally recognized unique identifier for your advisory. So if you put this out into the world and people want to talk about it, who you've never met before, they know exactly what number to include. Next up, I want to chat about the fact that when you open this GitHub draft security advisory, it also opens a private fork. So you and your fellow maintainers can collaborate on a fix to this security vulnerability and make sure that it truly does patch the problem before you release that. So you're collaborating on a solution, you're fixing the problem, you're writing up the advisory together, and this is all happening behind the scenes because it's important in instances like these that a bad actor who would potentially exploit the security vulnerability if they knew about it does not know about it until you're ready. So when you hit publish, this is what you're going to see next, is this beautifully formatted security advisory published right here in your repository. And this is positive for two reasons. Number one is that it lets your users know that they might need to upgrade to your latest version in order to avoid this security vulnerability. The second reason that it's good is that this is something people look for when they're considering whether or not to use your package. What is your security posture? Are you taking security seriously? Have you put out security advisories before indicating that you're listening to security researchers who are servicing problems to you? So overall, a very positive experience for your users to have this displayed. And next up, I will pass it over to Madison to tell us more about global GitHub security advisories.
Global GitHub security advisories are a little bit depository GitHub security advisories in the sense that they are hosted in a database on github.com/advisories. There are a number of other key differences between repository GHSAs, or GitHub security advisories, and global GHSAs. A repository security advisory is created by the repository admins, which is typically the maintainer of the package or project. They exist on the affected repository, so within the security tab of the repository itself, and they currently do not generate any automatic alerts using Dependabot or other alerting features. Global GitHub security advisories are chosen for inclusion by curators. There's an actual team of human beings reviewing these advisories and ensuring that the information is correct and accurate and including it within our database. Because it exists within the advisory database, it will also generate automatic alerts that are useful for users of your project, and advisories and alerts are machine readable, which is extremely useful down the line. What is the database itself, though? It is a collection of security advisories, currently a little over 16,000 total advisories that are within our supported ecosystems. Currently, the database has 8 different ecosystems, which are not all listed on this slide. And most importantly, this database is free to use. It's licensed under the Creative Commons Attribution 4.0 license, which means that the entire world open source community is free to use this information. We've talked a little bit about curation, and I would like to talk more about what that is. Advisory curation are reviews by subject matter experts. So these security experts here at GitHub focus on reviewing the advisory and CVE requests for validity and accuracy. They also take this information and enhance it. They add important key vulnerability details like the severity, the CVSS scoring system. They add weakness information by using the CWE system. They add affected version ranges, fixed version numbers, and a number of publicly available references. In addition to this, the curation team creates machine-readable data advisories. We map packages and versions to a unique identifier, a CVE, and a unique binary object within the package repository. So we can ensure that the package the advisory is about is in fact the package that you or your users are actually using. So at this point, we've talked about CVE a number of times. A CVE is a unique identifier for a vulnerability. The GitHub advisory database ingests new CVEs to create new advisories on a daily basis. In addition to that, GitHub also maintains 2 CNAs. We are CVE naming authorities, which means that we have the ability to assign a CVE to a particular vulnerability. The GitHub advisory database curation team is the acting CNA for GitHub security advisories, which means we can assign CVEs requested through the security advisory forms on your repositories. We also actively participate in the CVE community in a number of working groups and are very passionate about giving back, especially in open source. The GitHub Security Advisory Database has both unreviewed advisories and reviewed advisories. There are a number of key differences between both. Unreviewed advisories are typically vulnerability data that is generated elsewhere, namely the National Vulnerability Database that is operated by NIST. They are often missing package data, vulnerable version ranges, a number of other key vulnerability details, and they do not generate automatic alerts within the GitHub system. Reviewed advisories, however, contain data that is verified by GitHub. Our curation team reviews everything for validity, for accuracy, for completeness of information. We also map to package data to specific binary objects within the package registries, and we do generate alerts. So reviewed advisories in the database will generate Dependabot alerts, which will let your users know that there is a vulnerability. It will point them to the latest update and recommend that they fix it. This is an example of a global GitHub security advisory. You can see here at the top that it is listed as the GitHub Security Advisory Database, which is one way to know that you're not looking at a repository security advisory. You can see here that there are package details, there are affected version ranges, and versions, which is extremely important information to relay to your users. We additionally can add CVSS or severity information to the security advisory. This includes metrics about the attack vector, the attack complexity, the privileges required to perform an attack, the user interaction required, scope, and the impact on confidentiality, integrity, and availability. In addition to the severity information, add weakness information using the CWE system. The GitHub Security Advisory Database powers a number of different tooling, including internal vulnerability management here at GitHub. We use this product ourselves because we truly believe in it. This database also powers Dependabot alerts, which are alerts on any dependencies that are added, updated, or even removed from your project. The advisory database also powers NPM Audit, which is the Node.js application security scanning system for the NPM ecosystem. So anytime you run NPM Audit and get feedback that there are vulnerabilities within your system, all of that data is powered by this advisory database. There are a number of other use cases for the advisory database. There are specific ecosystems that we support that contain vulnerability data that can be found nowhere else. So how could you use the database? We have a GraphQL API that allows for webhooks for various automations for ingest advisories. We also have a website searchable front end where you can look for affected packages, specific CVE numbers, and a slew of other vulnerability information. There are a number of ways that you can contribute to the GitHub Security Advisory Database. We've recently released a feature that we are calling Community Contributions, where we are accepting feedback on specific advisories from all GitHub users. If you are reviewing a security advisory and you notice missing pertinent vulnerability details, impact details, or anything else that you might find useful, you are able to submit that information directly to our curation team for review. You can do this by submitting a pull request on our advisory database repository, or by clicking the Submit Feedback button directly in a global security advisory. If you would like information to be included within the database, you can create a global GitHub security advisory on your own repository. It will come again to the curation team for review. If it is within one of our supported ecosystems and about a valid vulnerability, very high likelihood that we can then include it in the global security advisory database. If you are operating outside of GitHub, and are a researcher or a maintainer, you can obtain a CVE from any one of the many CVE naming authorities. If a CVE is assigned to an issue, it again comes to our curation team for review. If it is within one of our supported ecosystems or within the scope of the database, we can review it, and there is a very high likelihood that we can then include that information. Thank you again for your time, and that is all we have for today.
Wow, that was a really powerful session, Amol.
Yes, it was great to hear how security researchers today identify and update vulnerabilities with GitHub Advisory Database.
Exactly. Isn't it amazing to see developers across the globe are collaborating to resolve zero-day exploits? And Amol, I'm sure you hear a lot of feedback from our clients about these features, correct?
Yes, in fact, very recently we worked with one of our enterprise clients to help resolve the Log4j vulnerability. By the way, Dhana, looks like our audiences who were on with us since morning could use a short break. What do you think?
Hey, you know what? That's a great idea. I think I'll get some coffee myself.
Okay, everyone, see you back after 15 minutes. Don't miss the amazing sessions and workshop we have lined up for you. See you.
everyone, and welcome back. I hope you were able to get some chai or coffee or something to eat. Amol, what do we have next?
I think there are some tweets coming in. Can we see some tweets?
Sure, that sounds fun. Oh, looks like Ashish11 Chowda is tweeting. He says, at the rate AWS Cloud, Git Secrets is such a great tool for beginner devs. Once I committed a API key which was being built, and I would like to make the repo private as I didn't know how to rewrite Git history. Well, Ashish, we've all been there, done that. As a security researcher, as a developer, we are bound to make those mistakes. It's great that you've learned from it. Thank you for tweeting to us. Do we have another tweet, Amol?
Yeah, let's bring it on. Okay, so this is from Goddess White A. Wow, what a great handle. So what it says is, at the rate GitHub India, amazing tips and session about security track today. And it helps us to learn a lot about what GitHub provides us, about GitHub security features, and also a lot about security vulnerabilities. Was so interesting. Thanks, Goddess White A. I'm sure, and I'm happy that you took something from the sessions that we did today, and I'm sure you would learn a lot more because there's so many more sessions going to be coming in. So, keep engaged. Then over to you.
Yeah. Hey, guys, thank you for tweeting to us. I would love to give them some swag. What do you think, Amol?
Yeah, I think we should do that.
Awesome. Ashish and Goddess with a CA, I hope I'm saying that right. Please tweet us your address, DM us at GitHub India, and we would love to send you some GitHub swag. Amol, what do we have next?
Yeah, so coming up next is a session by Joseph from our GitHub Security Lab, and he'll be talking to us about finding bugs in your code using CodeQL. So that's very, very powerful, guys. Over to you, Joseph.
Hello and welcome to this presentation from the GitHub Security Lab. My name is Joseph and I've had my dream job here at GitHub for the past 7 months now. I say this because I'm very passionate about our mission, which is to inspire and enable the community to secure the open source software we all depend on. My part in that mission is to make security easy for developers. And this is why I'm here today, to use these 30 minutes to give you the superpower of securing your code like NASA did. Well, this is not science fiction or a Netflix scenario. 10 years ago, when NASA's Curiosity was landing on the surface of Mars, NASA engineers performed a code review mid-flight. They wanted to check the software responsible for opening the parachute of the Curiosity rover during landing on the surface of Mars. And that was when they found a bug. The snippet on the slide that is written in C is not the actual code, but a fair description of what was really happening. The little bug that the NASA engineers discovered was that the function signature in line 1 expected an array of 12 elements, but an array of 3 elements will be passed as an argument in line 8. This means that the loop in lines 2 and 3 would read the correct memory coordinates just for the first 3 elements, but then it will go out of bounds, leading to random behavior. The NASA team found out that this case will prevent the parachute opening during the landing phase and lead to the crash of the Curiosity rover. The smart thing that NASA engineers did was that they didn't just fix the vulnerable code, the vulnerable instance, but they wrote a generic CodeQL query to look for variants of that vulnerability in all their code bases. What we call a variant is another occurrence of the same bug pattern at another place in the code, and they found 30 other variants. They analyzed that some of those would also result in catastrophic consequences, such as the crash of the rover. They fixed all of the variants, and Curiosity was able to land safely on the surface of Mars. If we now see the bigger picture here, and compare this scenario of fixing a bug mid-flight to that of fixing a bug in production. Then I'm sure you will agree with me that it is very late in the process of software development lifecycle. Last year, NASA sent another rover to Mars, but what have they done differently this time? They shifted security left by integrating CodeQL at the very beginning of their software development lifecycle by using GitHub. In 2 clicks, you can enable code scanning with CodeQL and get alerted about security vulnerabilities in your code. CodeQL is free for open source, and you can benefit from the continuously growing query set contributed by GitHub, by the community, and by top expert security teams like the one of NASA. That's already nice, as you can consume the world security knowledge to secure your code. But in today's presentation, I'm here with you to show you how you can not only consume, but be an actor in your use of CodeQL. Let's introduce security as code through the lessons learned from DevOps and quality assurance. One of the main levers of DevOps adoption was the introduction of infrastructure as code, where developers use code for setting up their own infra without the need to open tickets to operations teams. The fact that developers were writing code empowered them with further benefits, such as reading, contributing, and understanding what they were doing. Same for the world of testing. In the pre-agile days, developers and testers belonged to 2 separate teams. QA will find the bugs and report them back to devs. Nowadays, this methodology will not resonate with the vast majority of developers as they progressed in taking ownership of the automation around code testing. So we believe that what worked for testing and operations should inspire us for security. With security as code, we expect the security experts of an organization to codify security knowledge that is then shared under readable and executable form with developers. This sharing helps developers read, understand, and contribute the code, which facilitates a security culture. Therefore, think about security becoming a seamless observer of the day-to-day DevOps that don't intervene or affect DevOps speed. Security as code will be integrated and automated to the pipelines so that every time a security-related violation exists, actionable feedback will be generated. By the way, you hear more and more people talking about DevSecOps nowadays and how you can put automation in place for you. The vulnerability that is going to be covered by our demo is a SQL injection, and I just want to introduce it here for those that are not familiar with it. As per the meme on screen, this happens when a user is able to execute arbitrary queries on a database using SQL. The root cause of this bug is insufficient or missing input sanitization, allowing users to execute whatever database operation they want. The backend of the software on the meme will be similar to this. The text in purple represents the user input, which is being processed and sanitized. Same will happen though if the input will be processed with sanitization, but incorrect sanitization. So the idea here is that there is not correct sanitization in place. The query at the top of the slide inserts the name Clio into the database, but the second example shows that by passing user input that contains the parentheses and semicolon, a user is able to trick the backend into creating a second query that deletes the students table once and forever, while the third line with 2 dashes will comment out anything that the backend code will add after the user input. This is a very simple example, but in real life, user input flows in different places in your code base, through files and functions before reaching the SQL execution. In our demo, we will build a query that automatically finds SQL injections in those complex scenarios. Just before the demo, let's define two important concepts for our data flow query that is going to be part of the demo: sources and sinks. Sources are places in the program that receive untrusted user input, for example, a field in a web form. Sinks are places in the program where something malicious can happen if the malicious input reaches these places. In our example, the sink is a place where the SQL query is executed. So it's important for someone to understand that some vulnerabilities cannot be really executed. Think about some malicious input like here in the source, where malicious input is getting in the program, but it's never really executed. So the sink is never actioned. In here, we are looking for the data flow between the source and the sink. So the question we need to ask is a data flow one. Does this untrusted data ever flow to the point of executing a potentially vulnerable action? We can answer this question by identifying all paths from sources to sinks by using CodeQL. Notice that CodeQL allows users to query code in general, not necessarily for vulnerabilities. You can use it for any type of bugs or just to explore your code. We try to make these queries generic to find variants of vulnerabilities, and the biggest benefit you get is that you will now be able to codify your knowledge of a whole pattern about the vulnerability in an expressive query language. CodeQL language is declarative and logical. Declarative means that you or we describe what to find, not how to find it. Logical means that we will use operators like AND and OR to define conditions about your domain. CodeQL is object-oriented, taking advantage of features such as encapsulation and inheritance composition. However, as a total beginner myself a few weeks ago, the feature I found the most useful to get started with was the existence of a rich set of standard libraries that will make my life much easier because there will be reusable logic in the form of templates for me to use. And this made me really, really productive. For example, the templates that I'm going to use today in the demo is the one of data flow. And you are going to see what I mean with templates. It's going to be full of CodeQL and us having the chance to place some placeholders, and the magic is going to happen straight away. Our demo is designed for total beginners, and while our examples are in Java, you don't need extensive experience with Java either, as what I'm going to show you will be transferable to other languages that are supported by CodeQL, such as JavaScript, Python, Go, Rust, C, C++, and C#. It's demo time now. And here's our demo. Let's first check our vulnerable code base, which is the intentionally vulnerable code base from the OWASP Security Shepherd. We have a SQL injection vulnerability in a mobile app. The source is in line 98 and 99, where the program receives a username and a password in order to perform user authentication. The code is vulnerable because there's no sanitization happening in line 98 or 99 when the user input is retrieved, and it's being passed unsanitized in the database in line 147. Specifically, we have the raw query method, which is getting query, which is going to be our sink. So remember that the sink is where the vulnerable code is actually being executed, and in here is the first parameter of the raw query method. So just to recap quickly here, the user is inputting for authentication purposes their username and password in line 98 and 99, and in line 147, these username and password are passed in the database in order for authentication to be achieved. If you're familiar with SQL, let me just delete this. So if you're familiar with SQL, the structure of CodeQL may look familiar. We have the import clause at the top that allows us to reuse logic defined in other libraries. In this example, the Java's standard library. Then we have the query clause that describes what we are trying to find. It is made up of 3 parts, normally the from, where, and select. Let's start by learning about 2 of them, the from and select, and I'm going to add the where clause in a bit. From specifies the variables that are going to be used in the query. Every declaration in the from clause has a variable type and a variable name, while select specifies what the result should be by referring to the variables above. So, as per our SQL injection explanation, we need to arrive at those methods that receive user input. How do we do this? We first need to start by getting the set of all methods in the program, and then we are going to filter out by using the where those methods that receive user input. In the CodeQL Java library, to find method invocations, we can use the type method access. So far I have a type, and I now need to define a variable that I'm going to call it call. So if I read this query out to you in plain English, it will be from all the methods being invoked in the program here, give me all those methods. So if I run this, I expect CodeQL to give me back every single method being invoked in the program. So you see loads of methods here being run. If I click on one like parse boolean, we can see where it's being run. Clicking on other methods, on all those methods that are actually being invoked in the program. However, what we want are method calls that enable user input. This is because by enabling user input that is being passed and sanitized in the program, you are prone to security problems. To achieve this, we need to use the where clause that is going to impose restrictions in the from, and through these logical conditions, reduce the set you see on the right of my screen into those methods that we should really pay attention to. So let's use the where clause here. And now I'm going to use the call variable again, and I'm going to impose some restrictions in it. Look how I'm making use of the auto-completion when I press the dot, and how the dog is going to help me when I hover over the functions. So I'm going to use the get method, which is going to give me access to all of these methods individually. But I need something more now. I need to call specific methods individually. And to do that, I'm going to use the has qualified name, which, as you see from the auto-completion, is expecting a string package, a string type, and a string name. And you can see from the help we got here that it holds if the member has a specified name and is declared in the specified package and type. So the package we have here is android.widget. Everything I'm going to use here can be found in the database here on the left. I'm using the word database because CodeQL is transforming your code, your source code like in the one here, into a database in the form of an abstract syntax tree in order to discover code vulnerabilities or in general query the code. So in here we have android.widget. The type of the method is edit text. And I know for a fact, and you should know as well, that these methods that receive user input in the Android mobile app application are called get text. So what this query is asking CodeQL is, while initially, before adding the where, we started from all the methods of the program, we now want to arrive at only those methods that are the ones being named as get text. You can see that from here. So get text is the method that enables you to have user input. So if I run this query, I expect to come up with those invocations of get text. In fact, we have 3 of them. Let's see if all of them are vulnerable or not. Now, so far, we have the sources. Let's continue with the sink. And I want you, by the way, to notice the way I used chaining here with the dots like get method, has qualified name, This is another feature that CodeQL brings on top of SQL, which is expressivity with chaining. We can see from the signature of the hash qualified name that's expecting a package name, etc., etc. So you know that by chaining, you get access to very specific stuff that are going to make your code very useful to arrive to security vulnerabilities. It's time now to find sinks. To find sinks, we can use the same strategy, with the difference being that we are looking for a different method in a different package name. As we saw raw query, we saw it here, line 147. Yep. As we saw, raw query takes two arguments, two parameters, from which the first one here is the sink. So let's further refine our query by only asking for the first argument to be returned. The first argument, because it's going to be our sink. We can do this by using the type expression. So now I'm introducing another variable in order to get access to the first argument of the raw query method. It's not enough for us to come up with raw query. We want to come up with the fact on whether is the first argument of raw query being actually used. If yes, then we have a sink. So I'm going to use the expression type, the one I introduced in here, and then a new variable that I named arc that I have introduced. Finally, let's further refine the query by using the argument is going to equal the first argument of the raw query, i.e. the argument in index 0. So if I run this query, I expect to arrive at those raw query methods that are actually having a first argument being imposed. And by this, we know that they are prone to being the sink. Let's now see the real power of CodeQL. So we defined our sources and sinks. Let's now move to the data flow functionality of CodeQL, which is what is going to provide us with confirmed SQL findings. Luckily, the language comes with a rich set of standard libraries that have ready-made templates. As I told you, we need to just fill. On top of the file, we have some metadata that will help CodeQL understand what we are trying to do. Please ignore them for now. We then imported the taint tracking library, which is a template configuration to track untrusted user input, followed by the data flow path graph library, which is all about the visualization of the results at the end. We are defining a class here at line 11, which extends the taint tracking configuration. Again, this is to help us out, as the taint tracking configuration is a boilerplate. This is actually an example of how users can benefit from extensibility, and through classes, the expressiveness of the language is being highlighted. Another important feature on top of SQL is code reusability through predicates, like in line 14 and line 18. Predicates provide a way to encapsulate portions of logic in a program so that they can be reused. Think about them like methods and functions. Otherwise, I had to retype the code every single time instead of just using the method. What's important is how we are going to define the isSource predicate and the isSync predicate. We just have to override them using the code that we have already written from before, the one we wrote in here and in here. Just before filling in the predicates, let's briefly talk about this idea of data flow being represented by a graph with nodes, so that when there's flow from one node to another node, then you know that there's flow between sources and sinks, and you know you have a vulnerability because untrusted user input managed to arrive at the sink and actually being executed, being actioned. Otherwise, it will be untrusted user input that is never being exploited in a code base. So think about the nodes, the one node being the isSource and the other node being the isSync. So line 14 is our node 1, the source node, and line 18 is the arrival node, the sync node. So this exercise and this code here is all about finding confirmed data flow from sources to sinks. If there is any, then we have confirmed SQL findings. We can now fill the predicates by using the exists keyword. It's a new keyword that I want to introduce with you because it makes the code very readable. So it can read like there exists a method call such that when this method call is being accessed, like the get text one, you have confirmed user input being unsanitized in the database. We can just copy the code we used from before, put it here, and as I tell you about nodes, we need to express this source node to become the get text method at the top. So the way that this reads is there exists a method call such that when this method call is being the get text method, we have in the source node untrusted user input entering our code base. And we can now fill the isSync method using the same idea. Again, using like the autofill here, there exists a method access, we can name it call, such that this and this happens, or we can take from here. Let's fill it in, and I'm gonna read it out with you in the same way like before. Such that node as expression equals that. So the way that the sync reads is that there exists a method access. When this method access is the raw query, then the first parameter is the sync node. We now need to execute this code to arrive at confirmed SQL findings or not. And here we have two confirmed SQL findings. So if I click on the first one, we are getting the paths. There are two paths that are leading to the first SQL injection finding and two paths that are leading to the other. Let's explore all of them, starting from the first one. So we have flow traveling in 4 different areas in the program, starting from get text. So if you see on the left, you see that the username through the get text method is the hacker's entrance. Is then going to the login method where the username as check name variable is being checked to see if it's actually a login that exists in our authentication database. And then we can see the login signature, the function login. And finally, you have that this query where the untrusted username is actually being used is being passed into the database using the raw query method, where query is actually the first parameter and is the sync. So here's one pathway from get text, which is the entry of our program, into the sync with a confirmed SQL finding. There's another pathway though, which starts with the same way, being the username, but here, look at line 102 and compare it with line 117. The first one is checking for this condition equaling true, and the other is checking from the same condition equaling false. So in the lines 102 to lines 106, you have successful user authentication, but in lines 116 to 119, you have invalid credentials being passed. However, the SQL injection vulnerability still occurs because you have the same pathway. Even if the credentials are incorrect, like for example, an incorrect username or incorrect password, is still being checked against the logging method, which is again being checked against the raw query method. Therefore, you still have an SQL injection finding. And here we have another SQL injection vulnerability, let's say facilitated by two paths. First one is the, again, the get text method. This time is for the password variable, which is being passed in the login method, which has this signature here before being passed to the database. And finally, the password again is now checked for being false. So you see again lines 102 versus line 116, two different cases, but again, two different pathways towards a vulnerability. Going to the login method and finally being executed to the query. So you see how a variable starts and how a variable ends, and an attack is being executed. You can tell me here, you can argue a bit with me that, yeah, man, come on, this is just like a command find, etc. In a very small database with two occurrences of SQL injection and two pathways each time. But sometimes the path from a user input to the real SQL execution can be very long, with more than 10 steps across several files, several areas in the program. And imagine how difficult and error-prone would be for you to find those manually. Let CodeQL do it for you in the same way that NASA found the other variants of the bug I've shown you in the beginning of this presentation in their program. So to summarize here, the clever thing you can do is to generalize. So instead of making the queries very specific to search for these and that, you make the queries looking for the entry points and then make the queries to look for the destinations. And you don't care where the entry points passed from, etc., etc. You only care about an entry point arriving to a destination. If this is true, then you have a confirmed SQL injection finding. Code can be complex. We know this because we are doing cutting edge and state-of-the-art research. And by making our CodeQL queries very generic, we are able to secure the open source software that we all depend on. And this is our demo for today. Finally, you can start your CodeQL journey by visiting the following URLs that I'll also share with you in the description of these streams. And here we are, everyone. Thank you so much for your time, and thanks GitHub Constellation India for having me today. Thank you.
Wow, that's some great stuff. Thank you so much for sharing. Hey, Momol, I loved hearing about how NASA's Curiosity used CodeQL to scan their software around 10 years back. And this was done mid-flight. Isn't that just amazing?
Yeah, Dhana. And actually, this isn't surprising since CodeQL is one of the most powerful semantic analysis tool globally today. So who do we have next, Dhana?
Next up is Alvaro, who's going to talk to us about how to write secure code. Over to you, Alvaro.
Hello and welcome to this session. This is Need Help Writing Secure Code? OWASP has got you covered. This is a session about how you can, being an open source maintainer of a small or medium project, how you can write more secure code and leverage these OWASP resources. And for that, we will introduce different OWASP projects and what OWASP is in a minute. So my name is Alvaro Muñoz. I'm a principal security researcher with the GitHub Security Lab. I'm known as Pwn Tester in in GitHub and social media as Twitter. If you have any questions about the presentation, these OWASP resources or projects, you can always reach me in Twitter through this handle. So, as I said, I want to focus this presentation on helping the developers and maintainers of small and medium open source projects, because if you are writing code for a big or large organization, you will probably have security team that is helping you writing this secure code, right? You will probably have security trainings or security awareness. You will have things like static analysis or maybe dynamic analysis included in your CI/CD pipelines. And overall, you have the help of a team of experts in this area that will help you write more secure code, even in some cases through manual code review and things like that. However, if you are the developer of a small or medium open source project, then this is normally not the case. The reality is that you are writing a small piece of code that many, even organizations, may depend on, and that you are writing that piece of code yourself on your own, maybe with the help of some community contributors, but probably none of you are really security researchers or security engineers, or are not experts in the different subjects around security and application security. So how can you write more secure code if you don't know about all these attack techniques, attack research, attack vectors that malicious guys, bad actors are using? So first of all, you don't need to be familiar with that, because that is not feasible, and it's not even fair to ask you to become an expert, a security expert. But there are a number of things that you can do in order to help secure and improve the security posture of your open source project, even or without having to be a matter expert for application security. And this is what we are going to introduce you today and help you using these resources to even, without being a security expert, without having to know all the different details about these attacks, improve the security of your applications. So there is this quote that I like very much from Jim Manico. Jim Manico, by the way, is one of the OWASP project leaders. Specifically, he's the project leader of many of the projects that I'm going to introduce today. So he said that from his experience, all software developers are now security engineers, whether they know it, they admit to it, or they do it. And your code is basically now the security of the organization that you work for. And even though I really like this quote, I would extend it, because it's not just about the organization that you work for. If you are an open source maintainer, your code is also the security of all the different software organizations, products that are using your dependency, right? And this is very, very important. You're probably familiar with this cartoon from XCDC, where we have this, this puzzle of different components, and all this modern digital infrastructure is being held by a small project that is maintained by a single guy, maybe in Nebraska, that, like they say, they're probably somewhere else around the globe. And this is really, this is not a joke anymore. This is really the truth. We have seen that with OpenSSH bugs, with, for example, Log4j vulnerability last Christmas, where all Java applications, or most of them, were vulnerable to remote code execution because they were using Log4j and they were passing untrusted data into the Log4j library, right? So this has become critical. The security of these open source projects that we are all developing is now the security of this modern digital infrastructure. And we need help to improve the security posture of these open source projects. And for that, we have to use every single resource we have at hand. And we have the luck that OWASP is an organization that is putting a lot of effort in generating high quality resources to help you introduce or to help you increase the security of your projects. So if you're not familiar with OWASP, I invite you to visit the owasp.org website, and you will learn a lot about the organization itself and the different projects that they maintain. OWASP stands from Open Web Application Security Project, and they have many projects, as I said. Today, I want to focus on 4 of them, right? If you know anything about OWASP, it's probably around the top 10 risks or the top 10 web application security risks, which is probably the most popular OWASP project. Actually, is one of the flagship projects of the OWASP organization. However, the OWASP Top 10 project focus on telling you what are the different risks, so what not to do, and doesn't really help you in telling you, what to do, how to write more secure code, how to prevent those risks from being introduced into your application. So fortunately, OWASP changed the focus in the last years and have developed a number of projects that are now focused on how to do things in a more defensive way. So instead of focusing on the offensive perspective, it's focusing now on the defensive side of things. So now we have other projects that we will introduce today as the cheat sheet or the OWASP Top 10 proactive controls or the application security verification standards that we will see in a minute. So first of all, I wanted to talk about the OWASP Top 10. As I said, it's probably the most famous or the most popular one is the OWASP flagship project. And the purpose of the OWASP Top 10 was basically to raise the bar a little, right? So the problem is that a lot of people was using the OWASP Top 10 as a gospel instead of, as trying to improve or helping them improve the security posture of their applications. So you can see here that this is the top 10 risks of modern software. As for 2021, they change and they update this top 10 every few years. And actually, a few years ago, the number one, and since the creation of the OWASP Top 10, was the injection category. So think about cross-site scripting, think about SQL injection, command injection, JNDI injection. That was, for example, the vulnerability for Log4j. So that was the number one vulnerability for many years now. And we now see that it's number 3, which means that we are kind of improving in those areas that are more risky or that are more important for application security. And now other categories that were lower in this top 10 list are now becoming more important. Again, this is a list of things that can go wrong, like broken access control or how insecure design, etc. It doesn't really tell you how to protect against injection vulnerabilities, how to implement a strong access control, how to implement a strong cryptographic properties, etc. So even though this is a very good project, it's more focused on awareness, and it's important to be familiar with this list to know what kind of vulnerabilities are out there, right? But it may not even apply to your application or to library. So let's focus on other projects. And one of the projects that I really like is the OWASP cheat sheet project, which is focused on providing good security practices, right? So rather than focusing on the offensive side, you will find how to securely implement different security sensitive features such as authentication, authorization, or file upload, for example. In some cases, you will find very specific guidance, like, for example, a cheat sheet that may be for a specific language or framework. In some other cases, it will be more generic, like, for example, that example that I mentioned around how to implement file upload in a strong way, in a secure way. Even though we haven't really introduced the application security verification standard project or the OWASP Top 10 proactive control project, all of these cheat sheets are actually mapped to these other projects that we will see later. And as you can see here, we have more than 78 cheat sheets that are very useful, very specific, very detailed on how to implement things securely, right, from a developer point of view. So let's see an example. For example, we have this file upload cheat sheet, and this is just the introduction. You can see the table of contents at the right, and you can see that apart from the introduction, these cheat sheets will cover file upload threads, file upload protection, and a lot of other things like validation of the content type, file signature. But already in the introduction, you will see a summary of what can go wrong with the implementation of file upload and how to do that securely. Like, for example, it's telling you how to list allowed extensions, that you should validate the file type and don't trust the content type header, that you should change the file name to something that is generated by the application instead of taking whatever name is provided by the user, and a number of different recommendations and guidance that are very specific and are telling you how to do things in a secure way. So apart from that file upload, as you can see, we have 77 more cheat sheets. As you can see, and as I mentioned before, we have some of them that are very specific, like for example, maybe the Ajax security, and others may be more generic. Like, let me pick one, like for example, the HTML5 security may be more generic. So there are a lot of useful resources in this project, and this is a growing, a live project that is being growing for the last years, and there are many more cheat sheets that are being worked on. So the next project that I wanted to show you is the OWASP Top 10 Proactive Controls, and this one differs from the OWASP Top 10 in that these are really actions that developer can take into their software, right into their code, to help them prevent the common vulnerabilities that were mentioned in the OWASP Top 10 risk. So on one side, we have the OWASP Top 10 risk, which is telling you what not to do. And here is telling you what you should do. Things like you should define security requirements for your application. You should leverage or use security framework and library instead of rolling your own. This is how you should implement secure access to a database. And this includes many things in addition to SQL injection. So it includes things like how to properly configure the drivers, the connection, how to encrypt data at rest in the database, etc. How to validate the data, how to encode it for escaping it for different contexts, etc. So as you can see here, all these entries are telling you what to do and how to do it. So we will see that define security requirements is the first one, and actually is very important, right? And this is where the application security verification standard comes into play. This is another OWASP project. Is really one of my favorite ones. It's very detailed, it's very useful. So it was born as a way of verifying when a company was hiring a penetration tester to perform a penetration test around their applications. They didn't know, or how could they know that what the tester was testing was actually what they should be testing for, right? So there was a miscommunication between, or a gap between the company that didn't know about security and the tester that was testing whatever they thought it was required to be tested. So with this application security verification standard, what we get is a list of things that, for example, penetration tester should test for. So in this way, we are kind of normalizing the penetration test so that both the penetration tester and the company that is hiring these services can make sure that the application is properly tested. So that was like the original idea, the original purpose of this application. However, it has grown a lot in the last years, and now you can think about it as as a blueprint for creating the security requirements for your applications, right? So think about it as okay, I'm a developer, I'm not a security expert. I know that I need to define some security requirements before starting to write my code. But if I don't know about those attacks, about those vulnerabilities that my application may be vulnerable to, how am I going to write the security requirements, right? So ASVS project will help you with that, will help you identifying what should be the security requirements for your applications. So ASVS is divided in 3 different compliance levels. So level 1 is basically for low assurance levels, and is complete penetration testable. So it means that you can automate the whole verification of those requirements in an automatic fashion. And therefore, you can include that automatic test in your CI/CD pipeline, for example. So level 2 is for application that contains sensitive data, which requires protection, and is the recommended level for all or most applications. And level 3 is like a top tier, basically for really critical applications that performs a very sensitive transaction. Is probably not the case of many projects out there, but well, you can even take a look at what requirements are defined at this level and get you ideas of what a critical application should protect against. So in addition to these three levels of compliance, we have 14 different domains, right? So we have, for example, a domain around architecture, design, and threat modeling requirements, about authentication, about session management, about input validation, sanitization, and encoding, which is very important, about cryptography, etc. Right? As you can see in this slide, for level 1, well, you may not care about security requirements around the architecture, design, and threat modeling, but you have a number of requirements for authentication if you are using that. So first of all, you need to know what your application is doing or is gonna do, and then pick what domains are going to apply to your application. So maybe your application is not doing any kind of authentication or authorization or session management, and you can just strike out those domains. So for the domains that you think your application should or apply to your application, then you will have a number of requirements that you can add to your application depending on the compliance level. So let's see an example, for example, for the domain number 13, which is around the API security, and 13.2 is around specifically RESTful web services. Right? There is another one for SOAP. There is another one for different types of APIs. And here are the 6 requirements that are defined for the domain 13 and requirement, the second requirement. And as you can see here, we have things like verifying that enabled RESTful HTTP methods are valid choice for the user or action. So if users should not use delete or put methods, for example, you should not allow them to do that. So this is a requirement for your application that you need to make sure that is implemented correctly. And this is a requirement that is applied to the 3 levels, so level 1, level 2, and level 3. But as you can see, requirement number 5, verifying that REST services explicitly check the incoming content type, is something that may not be required for level 1, but is required for level 3 and level 2 and level 3. And you can also see what is the CWE, which is the common weaknesses enumeration, which is the vulnerability category that this requirement is mapped to. So with that, that's all the time we have today. There is plenty of information in the OWASP site. I really encourage you to visit the OWASP.org, learn more about the project. There are plenty more projects that may be very useful for you. So just learn about them, use them, and help us secure the open source software. Thank you very much.
Wow. Some great stuff there by Alvaro on how small and medium enterprises can write secure code using frameworks like OWASP.
Yes, especially since they don't have the big security teams and they don't know where to start and what to focus on, right? By the way, to all of the viewers watching us right now, please go to githubconstellation.com and enter our Capture the Flag contest. Of course, please keep engaging with us on discussions for GitHub Constellation, and also tweet us with the hashtag GitHub Constellation. Amol, what other frameworks would you recommend asking?
Well, Dhana, generally I have seen customers using frameworks like SANS 25, NIST, ISO 27001.
Hey, that's great. I love all the insights we are learning today. By the way, Amol, did you know I spent the first half of my career as a professional services consultant focused on security? So I'm loving all these additional learnings. So you know what? I'm going to step it up a notch since you are our security sales expert, and I'm going to play a rapid fire game with you. Are you up for it?
Yeah, that sounds exciting, Dhana. Bring it on.
Awesome. Why don't you tell me what's the most used attack vector by hackers?
Dhara, as per multiple studies by organizations like Gartner, Verizon, and other research bodies, more than 65% of successful breaches today actually target the application layer. So it's one of the inherent vulnerabilities in the code that is compromised to get access to the systems.
Whoa, So, can you name some breaches that happened because of vulnerabilities in code, Amol?
Yeah, in the recent times, we've seen many breaches, and to name a few, I think it was important ones were Equifax, SolarWinds, Facebook, Boeing. These are the names that come to my mind today.
Wow. So then, are there any compliances or regulations that would drive adoption for application security?
Yes, Dhana, there are many like ISO 27001, we have GDPR, we have AUTOSAR, CERT, RBI guidelines. These compliances give a very clear idea on controls to be followed for application security. Dhana, now let me ask you one question. So, since I know you've been reading up on a lot of important security research, do you know all the percentage of increase in the number of security attacks from 2019 to 21?
That's a good question. If I remember correctly, security attacks went up by over 270% during the last 2 years. Is that right?
Yeah, you're bang on. And you know why? One of the major reasons is digital transformation. As majority of the businesses are going online today with web and mobile applications. Okay, here comes another one for you. We all know that use of open source in today's enterprise software is going up significantly. But how much percent is it roughly?
I remember this from the session you did for us last week, Amol. So today, approximately 70 to 80% of code that forms the composition of software is open source.
Wow, good job, Dhara, I must say. Okay, the use of open source is the right way, but it also brings with itself the risk of security vulnerabilities and license compliance. So enterprises need to monitor this.
Yeah, thanks, Amol. By the way, here is a question that I hear a lot of the young developers out there asking, right? We keep hearing of this term shifting security left. What does that mean exactly?
Well, Dhara, this question deserves a very long explanation. But since I promised to play a rapid fire round with you, I will summarize my answer. Shifting security left means identifying issues and vulnerabilities in your code very early in the development lifecycle.
Thank you, Amol. Thanks for keeping it short. I'm sure our viewers appreciate that as well. But I'm curious, Amol, what are the benefits of shifting security left?
Yeah, that's a good one. So if a vulnerability is identified and remediated during development phase itself, the cost of fixing it would be 100 times cheaper than doing the same during the test or the production phase, because you have to redo the entire application if a vulnerability is found very late in the development life cycle.
Yep, that's true. And that makes a lot of sense.
Wow, this is getting interesting now. Let me ask you something. So you've been a BDM and you meet a lot of developers. What do you think are the challenges they face when it comes to application security?
Well, Amol, that's a good one and a tricky one. I have spoken to a lot of developers in my role, and I feel that developers currently take application security more as a burden, because they don't understand security. Also, thousands of vulnerabilities are thrown on them towards the end of the development life cycle. And also, they have access to so many tools that it impacts their productivity.
Yes, Dhana, it's very important that we educate and train developers on security. Every time a developer leaves their workflow to address a vulnerability, it takes them 23 minutes to come back to the same flow of work.
Oh my gosh, 23 minutes? That's such a waste of time. So, what can be done to help developers, Amol?
Well, Dhana, I think it's very important that organizations train them and also build a platform that could present developers with issues in a single pane of glass view. This would really give them a better experience.
Absolutely. And I'm sure all the organizations out there would be taking steps to do the same. Amol, yesterday you were part of the CISO panel discussion, right? Were there any specific concerns that all the CISOs had with respect to application security?
Well, yeah, it was a good session, and we did have 4 CISOs sharing their thoughts. So, generally, if you look at CISOs are concerned with security governance and would want to get a dashboard which could give them a complete idea on the health of their applications. Another major concern that I have generally seen is that engineering and security teams are working in silos today. Okay, Dhara, can you recommend some ways to ease out this friction?
Well, what I remember from your session, Amol, first of all, application security should be a top-down approach, right? And we need to empower developers with tools to simplify the identification and the remediation of issues, right? By the way, Amol, I had one last question for you. How does GitHub Advanced Security help address all these challenges?
Oh, that's my favorite question, and I'm sure I talk to customers and answer that every day in day out. So GitHub Advanced Security actually can help organizations in overcoming these challenges. So what we do is we help them shift left and also provide developers with a single pane of glass view to address vulnerabilities from all the different tools that they use today, thus improving developer productivity. Also, because advanced security is a tool which is very native to GitHub Enterprise, it's already integrated with overall GitHub ecosystem and relieves organizations of the pain that they encounter generally during third-party integrations. And the entire process of scanning and remediation is automated. So in fact, we are currently working on features that would provide developers with the remediation steps too, which today is a major challenge for developers. Then I think we have given our viewers a lot of insight. So let me stop here and let's move on from here. Then over to you.
Amol, but thank you. That was so educational. For all the folks who are watching us live, we don't want you to feel left out. If you have any questions for our security experts, please tweet us and use the hashtag GitHub Constellation. Also, you can use the discussions for a Q&A on what's going on. And why don't you tweet us some interesting security facts as well? And the best tweet can win some more cool GitHub swag.
So Dhara, on that note, we are super pleased to introduce our next speaker. His name is Kevin, who is also part of GitHub Security Lab. He will be sharing some practical tips on how to improve your security posture. So over to you, Kevin.
Hi, my name is Kevin Backhouse. I'm a member of GitHub Security Lab. In this presentation, I want to try and give some tips for open source maintainers on how to improve the security posture of their open source project. So this talk is actually really just a condensed version of a blog post series, a four-post series of blogs that I wrote last year about a project called Exiv2. So what's Exiv2? Exiv2 is a command line application written in C++. It's an open source project. And what it enables you to do is read, modify, delete, etc., the metadata on image files. So if, for example, you've taken a bunch of photos with your camera, the metadata might include things like GPS coordinates, and Exiv2 allows you to view that information and modify it or remove it if you want to. So how did I get involved with this open source project? So a few years ago, a couple of my colleagues were writing some training slides or training documents for CodeQL. And they decided to use Exiv2 as the example for the training that they were doing. I'd never heard of Exiv2 before, but I thought it'd be interesting to go and take a little look. So I did a quick audit, and I found a few potential security issues in Exiv2. And so I decided to report them to the project. So I went to the project page on GitHub, and unfortunately, I couldn't find any contact details for the maintainers of the project. And what I also saw was that other people had been finding similar issues to what I'd found in EXIF2, and had been reporting them by just creating public issues on the EXIF2 project GitHub page. So I kind of assumed that the maintainers of the project were okay with that, and so I thought, well, I'll just do the same thing myself. So I created this issue on the project page, and a few others in quick succession. I think I created 4 issues like this, and I still feel bad about this, because it turns out that the maintainers of EXIF2 were not okay with this, and in fact were really feeling like they were under siege from security researchers who were reporting bugs like this via public issues on their project, and it was distracting them from what they really wanted to do, which was create a useful tool for image metadata. They didn't want to spend all of their time fixing bugs like this, and the volunteers who are involved with EXIF2 are actually finding this really demoralizing. So I found this out when I got this response from Robin Mills, who's was the primary maintainer of EXIF2 at the time, and so he wrote this reply to me on one of the issues that I'd created, and he explained how they're actually just a small group of volunteers, and it became clear from conversations that I had with him how sort of under siege they were feeling, and how upsetting they were finding this continuous stream of bug reports. And so he asked me if I'd be willing to help out with fixing these bugs, and so I said, yeah, sure, I'm happy to. For me, it was really interesting as a project to work on, because I was interested to see what it's like dealing with these kinds of security issues, and what it's like to be an open source maintainer having to deal with these kinds of problems. And so my interest in EXIF2 has always been the security side, and I'm not a photographer myself, and so the actual image metadata thing is of relatively little interest to me, but I'm interested in hardening EXIF2 so that the other contributors to EXIF2 can get on with the stuff that they find interesting, and not having to deal with these security problems. So after I'd fixed the handful of issues that I'd found through manual audit, one of the contributors, called Dan, told me, well, he predicted that if I ran a fuzzer on EXIF2, that I'd find hundreds of issues. And so he showed me how to run AFL, the AFL fuzzer on EXIF2, and sure enough, I mean, it was just carnage. The results from AFL running it on EXIF2, and so you can see here in this report that it's saying that there's 260 or so crashes found in EXIF2. So that just seemed like a really scary number. But in fact, it turned out to be not quite as bad as it seemed at first. I mean, so it looked like there were hundreds of bugs in EXIF2, but in fact, I got started on fixing these things, and for the most part, the bugs were actually very easy to fix. I mean, it was usually just a case of sticking in an extra if statement to check that an integer was within certain bounds in order to prevent an overflow. So for the most part, these bug fixes were very, very simple. It's usually just a couple of lines of changes to the code. And after I'd created 24 pull requests and had them merged, AFL wasn't finding anything in EXIF2 anymore. So it seemed like the problem was solved, and that all the bugs were fixed. So that seemed like the end. It seemed like problem was solved, and we could declare it job done and move on. And in fact, did seem to be the case for quite a while. But unfortunately, 2 years later, these bug reports started coming back in again. And so this is one example from April of 2021, and it seemed to start a new series of these bug reports coming in again as public issues on the project page. And I'm assuming that the people filing these bug reports were fuzzing EXIF2, because these again look like fuzzer generated bug reports. So this time I decided, okay, we're gonna get professional about this, and we're gonna put some processes in place so that this doesn't keep happening. So we're really gonna shut this down, make sure that EXIF2 is really bulletproof and doesn't have any more of these kinds of bugs in it. And so there are three main things that we did listed out here. So the first was we created a security advisory process, so that people could actually, there'd be information on the repository on how to report a vulnerability, so that people stop creating these public issues. Secondly, we enabled code scanning. And thirdly, we enrolled EXIF2 in OSS Fuzz. OSS Fuzz is Google's fuzzing project for open source software. It's a free service provided by Google. It's really cool. So first of all, the first step in creating the advisory process is to create a file called security.md. So if you put a file called security.md in your repository, then that will be displayed on the security tab of your project. And it's a good place to give contact information. So if you find a vulnerability, this is who you should contact. And what we've also done on the EXIF2 security.md is specify what is and isn't a vulnerability. So for example, if you find a bug on the main branch of EXIF2, we don't consider that a vulnerability because that has not been released. So only if you find a vulnerability in a released version of EXIF2 do we consider it an actual vulnerability. So that's the kind of stuff that you can spell out in the security.md file. Oh yeah, and so I've actually just put my own email address in security.md so that if somebody finds a vulnerability in EXIF2, they just email me. I think not everybody's going to want to do that. I wanted to just get this thing set up quickly, but if you wanted to do this differently, you could create a security@myorganization.com type of email address to handle security reports. So the second thing that we do is we use the GitHub security advisory system. So if a vulnerability is found in EXIF2, then we create a draft advisory. And the draft advisory allows you to confidentially discuss the details of the vulnerability. You can also invite the security researcher who found the problem as a collaborator on the advisory, so they can discuss it there with you. And you can keep everything confidential until you're ready to disclose, and then you can hit the publish button and it goes live on your GitHub repository. The other two features of the GHSA system that are really, really handy are you can request a CVE through the GHSA. So that's now a really easy process. A few years ago, getting a CVE was a slightly cumbersome process, but now it's just a button click in your GHSA. And also you can develop a fix on a temporary private fork. So that allows you to confidentially develop the fix. And then at the time that you publish, that fix gets merged into your main branch. So everything goes live at the same moment. Okay, so the second of my blog posts in the series of blog posts, I jokingly called it Kev's 3 rules of bug fixing. So when you do find a bug in your project, I think it's really important to not just fix the bug, but do a couple of other things as well. So first of all, it's really important to add a regression test. And the reasons why I think regression tests are really important is, first of all, I mean, it means that exact bug can never happen again. But in fact, that's pretty unlikely that anybody's going to reintroduce the exact same bug again. But what it does, which is really important, is it creates code coverage for your bug fix. A lot of the time, a bug fix is going to be a new if statement in the code. And so by adding a regression test, it means that you have coverage for that bug fix. So if anybody's ever wondering, why is this if statement here, they'll see it hit. If they run the appropriate test case, they'll actually see that if statement getting run. And the regression test, because it adds code coverage, is also really valuable for fuzzing. So that goes into your fuzzing corpus and enables the fuzzer to get better code coverage of your code, which helps the fuzzer to be more effective. So now, second step is obvious, you fix the bug. But the third step is another one that I think is really important. A lot of the time, bugs are not unique. So if you have a bug, then there's a good chance you have that same bug elsewhere in the code base. And so it's really, really important to look for variants and make sure that you fix them all, rather than just fixing the one bug that you have a test case for. So this is an example where you can see those 3 steps in action. So this is one of the bugs that I fixed. So you can see that there are 3 commits here. So first of all, I have a commit where I added the regression test. Secondly, there's a commit where I fix the bug. And thirdly, there's a commit where I fix some variants of that bug. And the way that I found those variants was using a CodeQL query. So just a simple CodeQL query that looks for other places in the code where similar problems might have happened. So code scanning is a feature that GitHub has, and it's really easy to switch on. So all you need to do to switch on code scanning on your code base is you go to the security tab of your project and you click the little button that says set up code scanning. And what that's going to do is it's going to add a file to your project in the .github subdirectory. It's going to add a workflow file that will automatically run the CodeQL-based code scanning on every pull request. So that means that every time somebody submits a pull request to your repository, code scanning will run automatically, and it will warn you if any vulnerabilities have been found. But one of the cool things about it is it's also customizable. So the default suite of checks that are used by code scanning when you switch it on are quite conservative, and they'll only report it will only run the checks that we have confirmed a very high accuracy. So some of the other checks that have been written don't get run because they might have a higher false positive rate, and so we don't switch them on by default. But you can customize your own configuration, your code scanning configuration for your project, so that it adds more of those checks. If you find other checks that are useful for finding bugs that are relevant to your project, then you can switch them on. And you can also write custom CodeQL queries and add them to your configuration. So that's one of the things that we've done for EXIF2 is we've added a few custom CodeQL checks to find variants of bugs that have happened in the EXIF2 project in the past. So this is an example of a pull request where I'm adding a custom CodeQL query to EXIF2. And so we've now got the configuration set up so that to add a new check to EXIF2, all you need to do is drop a file with a .ql extension into this subdirectory, and then that now gets automatically run on every pull request. And so this was a simple CodeQL query based on one of the problems that was found at some stage, and so now that's being automatically checked on all future pull requests. So the final thing that we did was we enrolled EXIF2 in OSS Fuzz. So OSS Fuzz, as I mentioned earlier, is Google's fuzzing service, and it's really awesome because it runs 24/7. So your project is being fuzzed continuously, so the amount of computing power that Google are now throwing at EXIF2 is far bigger than I ever did when I was fuzzing EXIF2 manually by myself. And so every once in a while, one of these things will come in. As of this moment, we're completely clean. We have no open issues with OSS Fuzz. But it's really nice to have this running continuously, so that you know that you're always a step ahead of people who are trying to find bugs in EXIF2, because it's really hard for them to compete with the amount of computing power that OSS Fuzz is throwing at this to find bugs in EXIF2. So yeah, it runs continuously on the main branch of the project, and they also have a check that you can install in your repository so that it will run on every pull request as well. It will do something like 10 minutes of fuzzing on every pull request. So some bugs get caught almost instantly by that pull request check, and sometimes if it's a little bit more tricky to actually hit, then it might be like a week later or a few days later, where after a bug has actually made it onto the main branch, that then it gets detected by OSS Fuzz. But so far, these things have always been caught before we've done a new release of EXIF2. So it's really nice to have that extra safety happening. This chart shows the OSS Fuzz issues that have been found over time in EXIF2. So you can see that we started OSS Fuzz in August of 2021, and initially it found quite a few issues, and that was although we'd tried to iron out the bugs before we enrolled in EXIF2, it still managed to find a few more, because it's fuzzing so much more thoroughly than we were able to do when we were just running it kind of manually on our own computers. So it found a bunch of bugs initially, and then it really started to level off. And at this point, the only bugs that it seems to be finding are ones that have been accidentally introduced during development. So this is an example of one of the bugs that it caught, and this one made me really, really happy that it caught this. So what happened here was that there was a feature that was added, and it was added on the main branch, but also this was a feature that we wanted to actually roll out relatively quickly in one of the released versions of EXIF2 as well. So not only did it go on the main branch, but it also went onto the 0.27 maintenance branch, which will eventually make it into release, but it hadn't been sent out as a new release yet. And OSS Fuzz found this bug quite quickly. And one of the things that was really quite pleasing about this was that it seems that there's a bunch of external security researchers who are still fuzzing EXIF2 on a regular basis. And I got an email about a week after OSS Fuzz reported this problem to me. I got an email from one of these external researchers who'd found the same thing. I'd been a bit lazy about responding to the OSS Fuzz problem. I'd seen it, but I hadn't investigated it yet. But it was a lag time of about a week between OSS Fuzz finding something and then external people finding the same thing through their own fuzzing. So it shows how powerful the system is. So to enroll in OSS Fuzz is relatively straightforward. All you have to do is you have to send a pull request to the OSS Fuzz repository on GitHub, and it essentially needs to contain 3 files. It needs to contain a Docker file, which tells it how to install all the software that you need in order to build and run your project. And then you give it a build.sh file, which gives it instructions on how to build your project, and a project.yaml, which contains some information like the URL of the project and the contact details of the person who's going to respond to the bugs found by OSS Fuzz. Most of the work, to be honest, happens before you get to this point, because you need to make sure that your project is completely clean. So it actually took us a few months to sort of iron out all the bugs that we were aware of, so that we would get as few results as possible once we were enrolled in OSS Fuzz. And also we had to tinker with our build system because OSS Fuzz wants to be able to insert its own compilers and modify the compiler, the compiler flags and so on. So we had to tinker a bit with our build system in order to get it ready for integration with OSS Fuzz. And that whole process took a few months, but the final step of actually adding it was very straightforward. It just involved these three files. So to conclude, these are the four main recommendations that I have for how to improve the security posture of your open source project. So first of all, you should have a security process. So you should have a security.md with contact details. And I recommend using the GitHub security advisories when you do have a security issue in order to request a CVE and publish an advisory. My three rules of bug fixing are that you should not just fix the bug, but you should also add a regression test every time and also look for variants of that bug and fix them as well so that you're fixing bugs thoroughly. Code scanning is really easy to switch on GitHub, and it will help you to find extra problems in your repository. And you can enhance it with extra checks, either by turning on more of the checks that have been written by GitHub or other people, or you can even add your own custom queries to the code scanning configuration. And finally, continuous fuzzing is hugely valuable. And so we've done that for EXIF2, and it's really helping to stop new bugs from creeping into EXIF2. That's all. Thanks for watching.
Wow, wasn't that great? I am sure you all will follow the recommendations given by Kevin. Having a security process using code scanning tools and OSS fuzzing, I think that was really very important. So Dhana, before going to our last session of the day, what do we have coming up for tomorrow?
Oh my gosh, I can't believe the day is almost over, Amol. Well, before Amol gives details about our last session of the day, here is a quick overview of day 3. Tomorrow we are celebrating students and academics. So our keynote will be talking about all things GitHub education by Moira Hardek, who is a hubber. Then we have a fireside chat on innovation, culture, and entrepreneurship, the strength of India, with Kunal Shah, who's the CEO of Cred. We have panel discussions on future of hiring with bootcamp and industry leaders. We have a panel discussion where we deep dive on the creator economy and its impact in modern education. And we have so many more spotlight sessions, workshops for students and educators, and some context as well. Thank you so much, viewers, for tuning into our security track. Amol, do you want to share details of our last amazing session for all our viewers out there?
Sure, Dhara. Yes, we do have, in fact, a workshop by Shadi and Sebastian, my good friends, and they are experts on CodeQL. So this is going to be a live workshop. I would highly recommend you all check it out.
That's super cool, Amol. How do folks join the workshop?
So details will be coming up next, and that's it from Dhama and myself, everybody. Have a great workshop and see you tomorrow. Bye-bye.